100 facts about the Sun. 1. The Sun is a star located at the center of our solar system. Two. It is primarily composed of hydrogen, about 74%, and helium, about 24%. 3. The Sun's energy is produced through nuclear fusion, primarily converting hydrogen into helium. 4. It is approximately 4.6 billion years old, and is considered middle-aged in terms of its life cycle. 5. The Sun's diameter is about 109 times that of Earth. 6. Its surface temperature is around 5,500 degrees Celsius, 9,930 degrees Fahrenheit. 7. The Sun's core, where nuclear fusion occurs, is much hotter, reaching millions of degrees. 8. Sunspots are cooler regions on the Sun's surface, caused by magnetic activity. 9. The Sun's gravitational pull keeps all the planets in our solar system in orbit. 10. The Sun's gravity is about 28 times stronger than Earth's gravity. 11. The Sun emits energy in the form of electromagnetic radiation, including visible light, ultraviolet, UV, and X-rays. 12. Sunlight takes about 8 minutes and 20 seconds to reach Earth. 13. Solar energy powers Earth's climate, weather, and life processes. 14. The solar wind is a continuous stream of charged particles emitted by the Sun, which can affect space weather and Earth's magnetic field. 15. Solar flares and coronal mass ejections, CMEs, are powerful solar events that can impact satellite communications and power grids on Earth. 16. Solar panels on spacecraft and satellites use solar energy to generate electricity. 17. Solar energy is harnessed on Earth using solar panels, which convert sunlight into electricity. 18. The Sun's energy output is so immense that in just 1 second, it produces more energy than humanity has used throughout history. 19. Solar power is considered one of the cleanest and most sustainable sources of energy. 20. The study of the Sun is known as heliophysics. 21. Solar eclipses occur when the Moon passes between Earth and the Sun, casting a shadow on Earth. 22. A total solar eclipse happens when the Moon completely covers the Sun, revealing the Sun's outer atmosphere, the solar corona. 23. The solar corona is much hotter than the Sun's surface, reaching temperatures of millions of degrees. 24. The Sun goes through an approximately 11-year cycle of solar activity, known as the solar cycle. 25. During solar maximum, the Sun experiences increased sunspots and solar flare activity. 26. The Sun rotates, but not uniformly. The equator rotates faster than the poles. 27. Solar astronomers use a device called a solar spectrometer to study the Sun's spectrum. 28. The Sun is expected to evolve into a red giant in the distant future, expanding and engulfing the inner planets. 29. Solar observatories. Like the Solar and Heliospheric Observatory SOHO, continuously monitor the Sun. 30. Prominences are huge, arching loops of gas on the Sun's surface, often seen during solar eclipses. 31. The Sun's energy is essential for photosynthesis, the process by which plants convert sunlight into energy and oxygen. 32. Sunlight also affects human health by stimulating the production of vitamin D in the skin. 33. Solar activity can disrupt GPS and radio signals when the Sun emits bursts of charged particles. 34. The Sun's gravitational influence is responsible for the tides on Earth. 35. The solar constant is the amount of energy received from the Sun, the outer atmosphere of Earth. 36. Solar radiation drives Earth's weather patterns, including wind and ocean currents. 37. Solar power can be harnessed for heating, generating electricity, and even cooking. 38. Solar flares can interfere with communication systems and power grids on Earth. 39. The Sun's energy is stored in fossil fuels like coal and oil, formed from ancient plant and animal matter. 40. Solar radiation is the primary source of energy for the Earth's climate system. 41. The Parker Solar Probe is a NASA spacecraft designed to study the outermost layer of the Sun's atmosphere, the solar corona. 42. Solar telescopes, like the Daniel K. Inouye Solar Telescope, provide detailed views of the Sun's surface and atmosphere. 43. The Solar Dynamics Observatory SDO continuously observes the Sun, helping scientists understand solar activity. 44. The European Space Agency's Solar Orbiter mission to study the Sun's polar regions up close. 45. The Voyager 1 and Voyager 2 spacecraft have left the solar system and are exploring interstellar space. 46. The Hubble Space Telescope has observed the Sun's outer atmosphere and solar flares. 47. Solar scientists use instruments like spectrographs to analyze the Sun's spectrum and understand its composition. 48. The Solar and Terrestrial Relations Observatory Stereo consists of 2 spacecraft providing stereoscopic views of the Sun. 49. The study of the Sun's impact on space weather is crucial for spacecraft and astronaut safety. 50. Future missions may explore ways to harness solar energy from space for use on Earth. 51. Many ancient cultures revered the Sun as a deity, symbolizing life and energy. 52. In ancient Egypt, Ra was the sun god, depicted as a powerful deity riding a solar boat across the sky. 53. The Mayans developed complex calendars based on the Sun's movements and eclipses. 54. In Hinduism, the Sun is personified as Surya, a deity associated with light and warmth. 55. Many Native American tribes have sun dances as central rituals in their cultures. 56. The ancient Greek philosopher Anaxagoras was one of the first to propose that the Sun was a giant burning stone. 57. The Sun is a common motif in art, literature, and morphology, symbolizing enlightenment, energy, and vitality. 58. Various cultures have celebrated solstices and equinoxes as significant events related to the sun's position. 59. The sun is often associated with warmth, happiness, and positivity in poetry and literature. 60. Solar symbols, such as the solar cross and sunburst, have been used in art and religious iconography. 61. Solar cells, also known as photovoltaic cells, convert sunlight directly into electricity. 62. Solar panels can be installed on rooftops, in solar farms, or as portable chargers. 63. Solar power is a renewable energy source, reducing greenhouse gas emissions and dependence on fossil fuels. 64. Net metering allows solar panel owners to sell excess electricity back to the grid. 65. Solar energy systems can operate off-grid, providing power in remote or rural areas. 66. Solar energy installations have become more affordable and efficient over the years. 67. The efficiency of solar panels varies, but the best commercially available panels convert over 20% of sunlight into electricity. 68. Concentrated solar power CSP systems use mirrors or lenses to focus sunlight, generating high-temperature heat for electricity production. 69. Solar water heaters use sunlight to heat water for residential and industrial purposes. 70. Solar-powered calculators and watches have been popular for decades. 71. Solar panels on spacecraft provide power for instruments, communication, and propulsion. 72. The International Space Station (ISS) uses large solar arrays to generate electricity. 73. Solar sails are a concept for spacecraft propulsion that uses the pressure of sunlight to push a sail. 74. Solar-powered rovers, like NASA's Mars rovers, explore other planets and moons. 75. The James Webb Space Telescope JWST will be powered by solar arrays and will observe distant galaxies. 76. Space probes, like the Voyager probes and the New Horizons mission, rely on solar power for their long journeys through the solar system. 77. Solar panels on satellites in geostationary orbit provide telecommunications and weather monitoring services. 78. Solar cells are used to power instruments on deep space missions, such as the Hubble Space Telescope. 79. Solar power is crucial for long-duration space missions, like those to Mars and beyond. 80. The development of advanced solar technologies is ongoing for future space exploration. 81. Researchers are working on improving the efficiency of solar cells by developing new materials and technologies. 82. Thin-film solar cells are flexible and lightweight, suitable for various applications. 83. Tandem solar cells combine different materials to capture a wider range of sunlight. 84. Bifacial solar panels can capture sunlight from both sides, increasing energy production. 85. Solar tracking systems follow the sun's path, maximizing the amount of sunlight absorbed by panels. 86. Solar power plants can use parabolic troughs, solar towers, or dish engine systems to concentrate sunlight. 87. Perovskite solar cells are a promising new technology, with the potential for higher efficiency and lower costs. 88. Solar windows and building integrated photovoltaics (BIPV) integrate solar cells into architectural designs. 89. Floating solar farms on bodies of water are becoming more common, optimizing land use. 90. Solar-powered desalination plants can provide fresh water in regions with limited freshwater resources. 91. Solar power reduces carbon emissions, helping combat climate change. 92. Solar panels have a relatively low environmental impact compared to fossil fuel power plants. 93. Recycling programs are being developed to reuse materials from retired solar panels. 94. Solar power has the potential to provide energy independence and security for countries. 95. The growth of the solar industry has created jobs in manufacturing, installation, and maintenance. 96. Solar energy can provide power during natural disasters when the grid is compromised. 97. Solar-powered vehicles, such as solar cars and solar-assisted bicycles, are in development. 98. Solar-powered aircraft have set records for sustained flight, using only solar energy. 99. Researchers are exploring ways to increase energy storage capacity for solar power. 100. The future of solar energy includes continued advancements in technology, expanded adoption, and the potential to power a sustainable and clean energy future for humanity.